So happy to tell you a bit about what it is like to build a machine learning company around an open source project, and I will illustrate this a bit on the journey of DeepSet. So I'm happy to introduce you a bit to DeepSet, and also then to introduce you to a few, let's say, concepts and core learnings we made on our journey so far. Briefly about myself, my name is Milos. I'm one of the co-founders of DeepSet. Exactly, and I think not much more needed with regards to that. So let me start right away with our journey that started in June 2018. We founded DeepSet back then with the mission to actually find the most valuable and scalable way to bring natural language processing to the enterprise. Who are we? This was myself and two other co-founders. We knew each other for quite some years, all of us with a background in mathematics and computer science, actually. So this is an aspect we'll touch upon later in the presentation again, when we talk a bit about the different variations of machine learning. And we were quite convinced at that point in time that natural language processing as a discipline of machine learning is going to take off, is going to make a big leap, and is also going to then be, let's say, ready for the mainstream adoption. I want to take the opportunity to briefly frame a little bit the whole space we're in, because I was now throwing around some terms like machine learning and natural language processing. Just very briefly, the whole big spectrum we talk about is artificial intelligence. I would say a term that is not very well defined today. We refer often to it with regards to general artificial intelligence. What we mean is, in fact, anything that is somehow human behavior that is, let's say, mimicked by a computer. And I think I do not need to tell anyone that this doesn't need to be, or rarely has to do with true intelligence, but maybe rather also with rule-based systems or things like this. Machine learning as a discipline is, in fact, the paradigm of building machines and defining rules. This means we do not explicitly program every rule anymore, so we do not need to define them. We can train models. So we take data and put the data into an algorithm, and the algorithm then, if you want to say so, implicitly finds the rules. And this is how we then can build different systems, for example, for predictions or for classification. And one subdiscipline of that is deep learning. And deep learning is if you want to say so, can be distinguished in machine vision mainly and in natural language processing. So everything that is very high dimensional and highly context specific. For that, we usually use deep learning. And to give a brief distinction here also, what is machine learning, what is deep learning? Machine learning is so it's mainly about the main architecture from machine learning, which are artificial neural networks. You see them here, how they were used in the machine learning sense. So pretty, let's say, small, only few parameters and few layers. And what happened in deep learning is we were able to, through the increase of compute power, through cheaper computing, through more data also, we were able to actually make these networks deeper. So we could add more and more layers, what enables us again to learn more and more complex relations in data, and again to make the loop to natural language processing. If you think about language, which is highly context specific, where words have different meaning depending on where they appear, it makes sense to have something that can really capture the whole variety. And this is why the deep neural networks and deep learning is, in fact, the field of science we're in here when we talk about NLP. And yeah, as mentioned, in 2018, we founded the company mainly on the hypothesis that this deep learning based natural language processing is going to see a big leap. We were expecting some shifts in model architectures and ways of training those so that they become better performing. And it was great to see that by the end of 2018, actually, our hypothesis somewhat became true. Back then, Google Research published a paper and open sourced also the source code for an algorithm called BERT. And BERT is, probably you guys came upon it. If not, maybe the term transformers is familiar to you, because it's the same name of, in fact, the most popular NLP library out there, which is Hugging Face Transformers. These transformers were very new kind of deep learning based models, and they had a lot of, let's say, semantic capturing. They were very powerful. You see here what leap they caused in the end through their release for question answering, which is one of the most popular and most powerful also tasks you can perform with natural language processing. So this was really clear. Okay, NLP now had its magical moment, and it becomes now more practical. We can use very powerful models. We can really bring this whole idea of language understanding to machines. This is something that is now way more possible than it was before. So we threw ourselves after that opportunity and said, okay, let's learn what it is, what people want to do with natural language processing. So what are use cases they want to capture? So we used open source technologies. As mentioned, BERT was open source. There was then the Transformers library, the great library, which was evolving at that point in time, where we were contributing and also using stuff. And we worked with quite big enterprise customers at that time, and we're seeing, okay, what are the requirements? What is use cases they have in mind? What do they need in the end also for such a technology to really adopt it and really, let's say, pull it over to the mainstream? And we identified in 2019 that search information retrieval is, on the one hand, one core task and one solution to the core problems of those enterprises. And on the other hand, it was something that worked very well with these new transformer architectures. So it was clear that we want to throw ourselves after that opportunity. And this is why we then built a product around search based on these transformer architectures. And the product is at the core open source. It's Haystack. What Haystack does is it utilizes these transformer models, these BERTs and all the others. It's integrated with adjacent technologies that are needed, focuses on scale and production, so really that you can use it in a real world practical setting. And it's also targeted to an audience that is not an NLP researcher or an NLP expert who can really go down to every parameter, but rather someone who wants to use it and who wants to package it maybe into an own product. And of course, it's an open source product, but I will talk a bit more about this in a minute. What is also the rationale for doing that? I'm also happy to very briefly show you what is something you can now build with Haystack. So what kind of search or information retrieval is possible. Here are like some documents from IT security, so mainly newspapers. Let's say we're interested in ransomware, we're interested in WannaCry. We can ask something like how many machines were affected by WannaCry. This was like this big ransomware in 2017. And you see, we get here the exact answers. Here it's written computers. So this is what I mean with semantic understanding, semantic search. The machine interprets the question and understands that we mean with machine computer here. And this is then why we get these answers. Exactly. I would leave it actually, I would leave it with that and go back to the presentation also with regards to time, because I do not want to take the time from the presenters after me. Exactly. So this is what Haystack does. We'll talk about in a minute also about a bit more stuff, but important. Our journey is heavily driven by open source. In fact, in the beginning, mainly contributing and using open source products, like, for example, spaCy, like the Transformers libraries. And we moved to also becoming authors and maintainers of own projects like Haystack. We also have another project, which is Farm. And also on the business model side, when we talk about the company, we started off in the beginning, of course, through a lot of support and services around existing open source software, and moved now to offering complementary SaaS products around the open source product. But I will mention this also in a minute in a bit more detail. So much from our journey. And I mean, there are three core elements I would like to touch briefly upon when we think about, okay, we do machine learning and the product is open source. What are the core elements of such a company then? And I think it's very hard to say that these are the core elements. And I also want to say that each of these elements can probably be examined in way more detail, especially when talking about culture. But I briefly want to go into the motivation, the cultural part, and also give a bit of a glimpse of a mental model and ideas on how to approach the question of a good business model for an open source company. When we look at the motivation, I would say the very bold statement we want to make here right away is, in fact, there is no other way to really be meaningful in NLP without being open source. NLP is in the end something that powers products, and it should empower people who build products to embed natural language processing to embed search into the products. This means it must be developer-centric, and it must be transparent what's in there, and it must also be somewhat tailorable. So people need to be able to work with it and to go really down to the details when making it part of their products. This is one thing. It's not an end-user application. It's not nothing that is UI driven or whatever. It is really something that empowers other products and can rarely be a product for itself, at least when we think about end-user applications. The second thing is developers are really key decision makers in enterprises. And I know that this is quite a controversial discussion, I guess, because many proprietary software providers would argue that, no, you cannot do anything without the budget, and developers do not have budget. But what we realize is that the budgets are there, right? I mean, there's a lot of stuff going on out there. Companies and enterprises need to adopt technology. They need to make the next step, if it's natural language processing, if it's machine learning in general, or if it's any other technology that is out there. There is no way to do that. And often the people who hold the budget are not the ones who can really clearly evaluate the technologies, right? We always say, like, if you have a developer or a technical buyer in a room, you just need to get his nod. If he shakes the head, you're gone, and you can wine and dine as much as you want with the key decision maker here, or with the budget holder in that case. You're not going to make the enterprise adopt your solution, your technology. So it's really at the core to address also developers, and developers value open source for multiple reasons, of course. You should also be vendor agnostic, of course. But yeah, first and foremost, it's a quality sign. It's a quality sign if you have a big community, and it's also valuable to them to look into the product. And this is, let's say, the trust you need in the end to really make the enterprise adopt. One special thing in machine learning, and especially in natural language processing, is that so machine learning as a discipline is somewhat hybrid between, let's say, computer science and really, if you want to say so, mathematically influenced. So for example, my background is actually mathematics. I would say I'm better on the modeling side than on the software engineering side. So the discipline is quite hybrid. And this means that a lot of research is done, and the research is also quite cheap, because if you think about a pharmaceutical or if a vaccine that costs billions, and then the companies, after they spend these billions, they want, of course, to have the right to get a patent on that and to get the commercial benefit from it for 20 years. That's not the case in everything that's maths, right? Maths is something, it's like, it comes from the brain. There are a lot of smart people out there, and it's most meaningful to leave your footprint if you really share it with others. And that's the reason why our discipline and the state of the art is heavily research driven, also from universities, but also from large corporates. This means that at the core, the algorithms and the models are not proprietary. It's out there. People can look into BERT the moment it was out there. Of course, it was like a bit hacky code maybe, so it wasn't really put into a framework. And there were transformers and Hugging Face who gave that a bit more shape and all of that stuff. But the core logic is out there. So you cannot go beyond that. This means if you want to utilize this in something like a framework, again, it's like most natural to be open source as well, because people are used to looking into that stuff. And last aspect here, last probably for all products, but I feel in machine learning, where the market is really right now in this phase of forming and shaping up, it's really like at the core, getting immediate feedback to understand and to develop the product to product market fit. I remember, like, when I started in the industry 5 years ago, it was a lot about, okay, how is this AI market, machine learning market going to look like actually? How are we going to consume and use that? And there wasn't really, let's say, a clear understanding what people need, how people want to interact with it. Are people building it into their products, or will people will people be consuming it via API, whatever? And open source was actually a good way to understand that. You have a community, people use that stuff. You get a lot of small issues, but you also get big directions. You understand what is blocking them from using it, what is needed to bring it into production, all of that stuff. And this iteration speed in the end is something you cannot ensure if you're not open source. So these are like I would say, 4 core aspects. Again, the list can be endlessly long, but I tried somehow to condense it into those 4. Let me jump over to the culture part. And here, as mentioned, I think the impact of being open source as a company is way bigger than what I'm presenting now. I just take really, like, let's say, the most haptic example I could somehow define and find here. But I think it's open source is really like it's more than that. It's an openness in every decision you make, also as a management team, maybe, or as a leadership team, or as a product manager. When you go into a product direction, it's a different level of transparency you have in your organization if your product is already transparent and open source. Still, I've chosen to focus on the topic of customer orientation and customer centricity, because many companies, every company in fact on the planet, focuses on that. And if you look at the top management agendas also of old incumbent companies who are maybe in a completely different industry, everyone will have this on top. And I think many companies are struggling, and especially when we think about software, companies are often struggling in the proprietary space because engineering teams are decoupled from the teams who talk to the customer. So sales teams will come to engineering, they will tell them, hey, we need that feature, and engineering will maybe say, listen, I'm not sure if we can deliver, or why should I deliver, or I don't know, I never talk to the customer. You often tend to have like this gap. Being open source means every developer is somehow exposed and somehow in touch with the end user already, and this was for us very valuable. I mean, we had customers early on, we contributed early on, but we also had early on our own projects, and all of that somehow formed into one culture. So we treat, in the end, our community members, if they're contributors or if they raise an issue, the same as we treat our customers. And that's great to have it in the DNA, because in case you have a paying customer who pays you for something, the engineering team they're there, they understand it, they have it there because they like to be there for other developers and the community. They like to solve issues and to answer to Slack requests. So they're also quite open in the end to do this for every customer. So this is really something we felt was great. This mentality of treating everyone who uses our product like a customer and giving the dedication. And also, I think one great thing where many companies work on is seeing the customer or the user as your teammate, right? In the open source community, it's not just that people post issues, people contribute, and people give feedback, and people spend time with your product. We should appreciate that, of course, because it's not natural that someone maybe in his spare time over the weekend sits there and looks into the product and prototypes with it, because this is valuable feedback we get. And understanding that this means we are in one team also to a certain degree. We develop this together because you give me insight and I maybe do some building. This is really awesome stuff, and it's really helpful also when interacting really with them, with enterprise and commercial customers who then tend to also treat suppliers and vendors often a bit, let's say, hierarchical. This really helps to keep up the good mood and to really also be always have that in your DNA and deliver. Let's talk about the business model part. And the business model part is something I really, in the sense of open source, I want to give the credit right away to the person who shaped us here and influenced the thinking the most. So who I'm going to pick up now, Joel Spolsky here, and mainly his strategy letter number 5. I think it's almost 20 years old, but it's a great piece of work. And it really is a mental model that we try to fit very well also into how we think about the business model, how we think about commercial product, what we offer around it. So this is why I'm happy to introduce it here. But as mentioned, I just wanted to give the credit right away to Joel. So the core theory comes from microeconomics, and it's in fact about the idea of substitutes and complements. Probably most of you know it already, but I still want to briefly look into that here. So let's say you have a product, and then there's another product which is either substituting your product or it's complementing your product. So what happens if it's a substitute is the moment you raise a price for this product, your demand goes down. So that's somewhat obvious if you think about, let's say, Coke in the can and Coke in the bottle. If the Coke in the can, I don't know, is becoming twice as expensive, the demand goes down. One important consideration to make right away here, because of course everything in here is related somehow to open source, we need to keep in mind that every software, even if it's free of license, what open source is, comes at a cost, right? So if you open source something, there is still work involved to make it work in the end, and to maintain it and all of that stuff. So this is really important to keep in mind, that there still is a price that might influence you here. And what happens in return for the other substitute here, of course, when the prices go up and the demand goes down here, the demand for this product here rises. Of course, because you have a pure competition on price. So transferring this to an open source world, if I'm an open source software provider and I try to sell on, let's say, just some plain enterprise license, which is not very well defined, it might end up being in a substitute situation, right? Because it's not clear what the value is. I put an increased price tag on something that was out there that was actually not priced. Or if you think about making some stuff more difficult, I don't know, increasing the total cost of ownership, this is all stuff that actually leads to you fighting against your own product and cannibalizing your own product. The more powerful thing is, of course, think about a complement. This means if we have a complement now and the price goes down for this complement, what happens is the complement will be more used. And if the complement is more used, my product, so I'm commoditizing the complement to a certain degree, my product will be demanded more. So going back to the open source world, if I find a way to say, okay, this open source product in itself, it's so valuable, and I reduce the price, I reduce the total cost of ownership, I make it even easier. So I drive adoption up, I make it a commodity, everyone can use it, enables me also, if of course I have a solid complementary product around it, enables me to get more demand and more adoption also on this complementary commercial product. So this means the complementary idea is in fact the powerful idea here. And what I really like about Joel is he says, in fact, when you look at this theory, what you should aim for is you should make this complement, you should make it a commodity, right? It should be easy to adopt. It should be used all over the place. And if you ensure that, your product will also receive and reach more and more and more demand. And open source software, or open source as a model, is something that actually drives this commoditization of software up, right? Because as mentioned, it's cheap to distribute, and if you put effort in it and make it valuable for a community, that the community can also cheaply, at relatively low total cost of ownership, adopt it, you still have a lot of place for a commercial complement, and you still have a market. So you shouldn't limit yourself when you think about, hey, shouldn't we make this as easy and as great as possible? Some practical examples on substitutes and complements. I think the idea was quite clear, but yeah, again, if we think about bread and butter, maybe if bread becomes extremely cheap, more people buy bread, and if the price for butter stays the same, the overall demand for butter will go up, because the total cost of ownership for the combined product compared to the value it provides me is increasing. And this is I think a great way to think in this tenuous field of how to commercialize open source in the end. Machine learning as a discipline, I would say, this is maybe bold again, but I would say offers actually a lot of opportunity to deliver a very whole, powerful open source complement product, and to have like, or an open source core product, and have a valuable complement around it. So when you look at Haystack, for example, Haystack is, if you think as an architecture, it's something that consists of building blocks. These building blocks fulfill different functions, and under each building block, you can configure very powerful technologies. You can configure, for example, in a reader model, different transformers. In the document store, you can take, I don't know, Elastic, Solr, whatever you want. So you have a lot of choice there. And Haystack also allows you to easily put it together such that you have like a robust pipeline, a scalable pipeline. You can wrap an API around it. You really solve, in fact, a lot of the purely technical complexity. Yeah. What you still have as opportunities, and this is a bit how we think about it, is to have like valuable supporting tooling around it. For example, easy configuration. You can use the tool. You can try out a lot of stuff. Every developer can do this, but probably in an enterprise setting, many developers wouldn't also love to do that. They would love to have, let's say, pre-optimized pipelines or stuff like that. So they want to take a bit of the heavy lifting away. Or if you think about monitoring, you think really about a large scale adoption. Yeah, the free product is great. It's used. It's in production. Maybe at some point in time you feel like I'm maybe a bit overwhelmed. I need to get more transparency on this, or maybe I don't know. I need to know better what is going on there. Should I upgrade the model? Shouldn't I upgrade the model? And the last thing is also labeling and tailoring. So domain adaptation. Again, many, especially companies and enterprises, face the challenge that they have a very specific language they use, for example, and they want to adjust it to this particular language. So this means this is like really getting even more value out of Haystack in that moment. These are all options for valuable complements that are somewhat orthogonal to the actual open source product. And here's an example how this is captured, for example, how we think about it in Haystack Hub, for example, through annotations. The tool actually is also available for free, but thinking about streamlining the process, again, taking a bit away heavy lifting, having all integrated in one platform such that you can really say, okay, in a complex enterprise setting, this is a valuable add-on to my normal search pipeline I could build free of charge, or as mentioned, nothing is free of charge, but at least with the license-free software. Yeah, so I think I can even make it in time, which is great. Regarding to sum this briefly up, maybe. So I think what you should take away from this is, number one, NLP made a big leap, and it really seems like we're ready to enter the mainstream. There are great companies out there who are also supporting this, from Transformers to Gina AI to Milvus. So there's a lot of companies going on, all of them open source also. So yeah, I would say all of us are ready to bring and to meet mainstream markets. At the core, still, NLP must be open source. This is a strong conviction, and proprietary solutions is nothing we expect to win in this market. Exactly. Then maintaining open source projects is something that can be also beneficial when thinking about the sales organization or delivery organization further down the road when the companies start to commercialize, because being open source and maintaining a project is something that translates very well also into customer centricity. Exactly. Commercial open source means looking for the complement. So aim on commoditizing the open source product, aim on reducing the total cost of ownership for the open source product as much as you can. It's not going to harm and it's not going to limit a business opportunity if you're very able to find a meaningful complement. And last but not least, of course, Haystack is a great tool for introducing NLP into products. So yeah, we're very happy if you join our community or follow us on one of the channels, or mainly if you have questions, or as we're hiring right now, also join our team at deepset.ai/careers. You will find the current postings. And with that, I'm happy to conclude. So thanks a lot for the attention.
Thank you so much. I think there's one question in the Q&A. Can you see that?
I have to stop my screen share briefly.
I can read it to you.
I see it. Yeah. Okay. Do you find limitations on an open sourcing state-of-the-art academic research when developing for a business? So for us, to be honest, the open sourcing of the research it enables our business, because still, even though I said in the beginning the research is still relatively cheap, it's still something we do not do at the core. What we research on is a lot about how can these models be used in practice, how can we adapt them maybe to a certain text corpus, and so on and so forth. So for us, it's rather enabling. And I think the institutions that open source state-of-the-art research are often, of course, also the big tech players. The rationale behind it might be different, but probably driving cloud adoption up and stuff like this. So we think that for us, as mentioned, it's not limiting. It's the contrary. It increases trust. Everything we do in domain adaptation makes the community more aware of the fact that the stuff works and can work for them. And this is actually what we do. We somehow try, as mentioned, to move into mainstream market to cross the chasm. So this is why for us we do not see any adverse effect of, or see any risk of, or any need to actually not disclose any proprietary models or anything we learned. I hope that answers the question. If not, happy to take this also to a chat afterwards. And I see Jeff also has a question. Do you patent as something to explore, worry about in the space? We do not see patents. I can, so we do not see patents. I know that there are some people who start patenting some NLP algorithms and stuff, but really what we see, what is adopted is not patented at all. And we are also not worried about it. And I think the reason for this is, I mentioned it, the discipline is partly computer science and partly maths, right? And I always love the background and the story of the Black-Scholes formula. Two researchers had, in fact, the same idea of solving a partial differential equation in option pricing at a time when there was no Twitter and where there rarely were conferences and stuff. So this is really like, it's a thought two persons have at the same time, because it's relatively cheap to experiment on it. Whereas, of course, I cannot find a vaccine against COVID if I do not spend 1 billion on experiments and stuff. And this is why I think patents is something that doesn't really and won't probably find its way into machine learning, because as mentioned, GPT-3, the training cost was 10 million, which is high for a startup, but still that's something many organizations, Stanford University can afford that as well. And this is why we think patents is nothing that would bother us so much in our space, at least. I hope that answers also the question. If not, I'm also happy to take that not offline, but to another online channel.